Good morning everybody. I am Anusha from CSC department working as Assistant Professor in Institute of Aeronautical Engineering. In my videos, I am discussing about programming with objects which is based on Java. And now we are discussing about the question banks regarding the first unit, which is OOPS concept and Java programming. So the first question is to differentiate this and super keyword usage in Java. The this keyword is usually used to refer the currently working objects. So we can also use this keyword for other things, like when we want to pass the invoked object to another method or something like that, we can use this keyword. So basically it is used when a method will need to refer the object that it invoked. It can also be used to refer to the current object and also to the object on which the method was invoked. So, and this is also this keyword is a reference variable which refers to the current object. Now, this can also be used to resolve namespace collisions. Like for example, let's consider this example. In this, we have the instance parameters and the formal parameters as the with are mentioned with the same name. They both are, because that is generally what we use. We keep the local and the instance variable the same name, so there won't be any confusions. I mean, like for easy understanding. But this may lead to the confusion between the attributes. So in order to resolve that problem, we make use of this keyword. So here, both the local and the instance variables are referred with the same name. So in order to identify the instance variable, we make use of this keyword. So what happens, whatever variable is being passed, these are the local variables. So these variables are being assigned into the instance variable of that particular object. So so this is one of the main use of this keyword to aid in namespace collision. These are also the different uses of this keyword, wherein it can be used to invoke the current class constructor. It can use to invoke the current class method. It can be used to return the current class object. It can be used to pass an argument in the method call and in the construction call. So these are again different uses of this keyword. Now, if you go into the super keyword, it is mainly used to refer to the immediate parent class object. So it is a reference variable that will refer the immediate parent class object. So using the super keyword, we can invoke the parent class constructor or the parent class member, which can be either a method or an instance variable. So in case if it is a member, then we can access that member using the first form super.member. So this member, it can be either a method or it can be a instance variable. So and the second case is the method by which we invoke the superclass constructor. So when we invoke the superclass constructor, it will invoke the constructor of the immediate superclass, and also it refers to the superclass the super keyword which will refer to the immediately above the superclass which lies immediately above the calling class, and it should be always the first statement executed in the subclass constructor. Always super constructor. If we are invoking the super constructor, then that should be the first statement in the subclass constructor. Next, list the different types of inheritances supported by Java with suitable examples. So these are the various type of inheritance available in Java. Single inheritance, hierarchical inheritance, multi-level inheritance, hybrid inheritance, and multiple inheritance. In single inheritance, you have only one level of inheritance, wherein you have one superclass, and from that super parent class, we have the subclass or the child class derived. So we have one superclass and one subclass. So that is single inheritance. Now, hierarchical inheritance is having more than one class in the same level. So we have from one superclass, we derive more than one subclass. Then in multi-level inheritance, we have more than one subclass in different levels. So we have the topmost superclass, and from that superclass, one subclass is generated, subclass 1, and from that subclass, the subclass 2 also will be generated. So the subclass 2 will have the properties of these superclass as well as the subclass 1. Next is the multiple inheritance, wherein this is achieved using interfaces. It does multiple inheritance cannot be implemented using extends keyword. They are implemented using interfaces. So in order to resolve the diamond problem. So in multiple inheritance, we will have more than one superclass, and from that superclass, subclass are derived. So this subclass will have properties of the superclass 1 as well as superclass 2, and this is implemented using interfaces. Next is the hybrid inheritance, wherein it is a mix of the hierarchical and the multiple inheritance. So in this case, we have from one superclass, we have more than one subclass derived. This part is the hierarchical, and from these subclasses, these two subclasses form the parent class for the third class. So here we have multiple inheritance involved. So these are the various types of inheritance implemented in available in Java. So let's look into a simple example of simple inheritance. Here where we have one class A, from that class A, class B is extended. That means from class A, class B is achieved. So class A has the instance variable ij and show ij method, which will display the I and j values. Whereas in class B, it has an instance variable k and show k and sum method. So these are the two methods which is exclusive of, which is particular for B, and B will have, since B is extended from A, it can access ij and show ij methods. So here in show k, it is displaying the instance variable k, and some method is adding the whole ij and k values. Now you can create the object of B. So here, let's say we are creating the object of B, and this as well as object of A is created. So we have an object of A which is having the name super OB. So this will have ij and show ij method. So super OBs means it is I value is set to 10 and this value is set to 20. When you call the show ij over this, it will display the I and j values. Next, we have the subclass object B named as sub OB. So since B is inherited from A, it will get the I value, j value and its own k value. Then the show ij method, show k method, and sum method. So in the show ij method, it will display the I and j values of sub OB. When you call show ij on sub OB, it will invoke. When you call show ij on sub OB, it will display the I and j values of sub OB, which is 7 and 8, which is initialized here, and k is set to 9. And then when you call show k, it will display 9. So you get these two lines. And then it is we are calling sum. So when sum is called, it will add the values of 7, 8 and 9. Since sum is called over sub OB, it will add 7, 8 and 9, and then the sum value will be displayed as 24. So this is achieving simple inheritance using simple inheritance in Java, wherein from one class another subclass is derived. So only one level of inheritance is available here. In the second case, we have multi-level hierarchy, wherein we have one base class. From the base class, you have the subclass A, and from that you have this subclass C. So there is three level of inheritance. We have the base class, subclass A, and from the subclass C is extended from the subclass A. So here in the constructor of base class, it is displaying the base class constructor, and in the subclass A constructor, it is displaying subclass A. Likewise in subclass C constructor also. So when we create the Okay. So let's say we have now we are creating an object of subclass C. So when subclass C is created, what will happen? It will invoke the constructors from the topmost level. So the topmost constructor will be invoked from that. So here we have the base class first, then the subclass A, then the subclass C. So the base class constructor will be invoked first, then the subclass A and the subclass C constructor will be invoked when you create an object of subclass C. So that is when we create an object of subclass C, we get these three lines, and then you are calling the from using subclass C method, you can since they are inherited, it can invoke the display base, display subclass, and display subclass C methods. So by creating an object and calling these methods, you get these three lines. So this is multi-level hierarchy. Next we have the hierarchical inheritance, wherein we have class A. From class A, class B is extended, class C is extended, and class D is achieved. So from A, class B, class C is achieved from A, class D is also obtained from A. So all these three classes will have the properties of class A. So you can call, we are creating an object of B class, and since B is inherited from A, it can access the print A method as well as print B method. So you can call, using this object B, you can call the print A method as well as print C. Now similarly for C, it can call print A and C method, and using object D can invoke A and print D method. Since A, B and C, B, C and D are inherited from the class A. So that is hierarchical inheritance. Next is list some of the standard overloaded methods in Java. So overloading methods means they will be having the same name but different signature. That means signature means the parameters passed will be different but the method name will be same. So these are some of the built-in methods which is available in array class. So there is a class named arrays which is used for implementing arrays. So using this array, in this arrays class, there is a method called as binary search which will implement the binary search algorithm, and this binary search algorithm is overloaded in 5 different ways. So the first one will be taking that array and the key value to be searched. The second binary search will take that array and the from index and the to index and the key value to be searched. Now this is taking a character array and the character key. Similarly, the binary search for character array, the from index and the to index. Likewise, we have this double. So there are many different ways by which binary search is overloaded. So you have the on the double array and the key. So here all the algorithm will be the same, but the parameters passed to it is different. Since we have in the first case we have two parameters passed, wherein byte array and byte key. In this case we are having even though it is 2 parameters, the type are different. Here it was byte, here it is character, here it is double. So this is an example of overloaded method in Java. Similarly, we have append method, which is inside the string builder class. So the append method will append the string representation of the Boolean argument to this. If it is in the first case, it will append the Boolean argument. In the second case, it is taking character. In the third case, it is taking character array. So likewise, these are the various overloaded method of append method, wherein the name is the same but the parameter passed to it is different. And a string builder uses a mutable sequence of characters. This class provides an API compatible with string buffer with no guarantee of synchronization. That means there is no synchronization of a string builder class. You cannot achieve synchronization in string builder class. Next is to describe the enumerator type with an example. So enumeration is, they are basically enumerations are self-declared constants. They are self-typed, self-declared constants. So they are created using the keyword enum. So once we create, we here in this case we are creating an enumeration named as apple, and they are having some variables in it, some constants. So these are different. These are all constants in it, and they will be given some values to it. So you can create an object of that enumeration in this way. By this statement, you are creating an object or a variable of the enumeration type. So let's look into an example. So here we are creating an enumeration named apple with the keyword enum. So you can assign the value of enumeration. You can assign the value of some enumeration. Here enumeration value is reddel. So that reddel value will be assigned to AP. AP is an enumeration variable. So to this we are assigning the reddel value of apple enumeration. So this is how we apply. And when you print that value AP, we get the value as reddel itself. Now we are assigning the golden del, and we can compare two enumeration constants. So here we are having golden del, and we are comparing it with apple.golden del. So they both are equal. So it states apple contains golden del. So you can assign an enumeration constant to an enumeration variable. You can compare two enumeration values. You can use them as a switch control statement to control a switch statement. This AP is taken golden del. So this AP will be compared with all these enumeration constants, and it will find that it is matching to this golden del. So the golden del case will be executed. So golden delicious yellow displayed will be displayed in the output. Next is to distinguish between a constructor and a method with an example. So constructor generally is used to initialize any object. So they will be having the same name as that of the class. So constructor is used to create an object. Is used to create an object and initialize it. It can be invoked implicitly by the system. So while the object is created, the system, the JDK itself will be invoking the constructor. It is invoked when a new keyword is used to create an object. It don't have any return type. It initializes an object which is not existing, and it must have the same name as that of the class, and it cannot be inherited by a subclass. Whereas methods are used to execute certain set of statements. They can be invoked during a program code. The method is invoked when it is called, and it will have a return type. It can be invoked only on an existing object. It cannot have the same name as that of the class, and it can be inherited by the subclass. So these are the basic differences between a constructor and method. Next is to demonstrate about data abstraction with an example. So data abstraction, it is a property by which we are hiding the implementation details, and only the essential details are displayed to the user. It is a process of identifying only the required characteristics of an object, ignoring the irrelevant details. The properties and behaviors of an object differentiate it from the other objects of similar type, and also help in classifying objects and a group of objects. So when let's say we are having a class. We have a class named A. In that class we have a lot of instance variables and methods. So when you create an object of this particular class, we are hiding the implementation details of these variables and methods, because let's say we are creating an object A using the we are creating an object A of this particular class. So what happens here, when this object is created, it can access all the variables present inside it, and as well as the method. So the user who is accessing this object variable need not know how these methods are implemented. You just invoke them. And also to achieve abstraction, there are two ways. You can either use abstract classes or interfaces. Interfaces and abstract classes are another two different ways by which you can achieve abstraction. So abstract class is a class that is declared with the abstract keyword, and all the methods inside the abstract classes uh, uh, are abstract. That means they don't have any implementation. So if it is a method, we just have the method name followed by bracket and a semicolon. So it will end with an semicolon. You won't have any, there won't be any implementation of this abstract method, which is defined inside the abstract class. And these abstract classes may also contain concrete methods, where concrete methods means those methods with implementation. Those are having some values, implementation of them, body for that. And so whenever any method is defined as an abstract, then the class which is inheriting that particular abstract class, let's say we are having a class named A which is abstract, and you're having a class B which is inheriting from class A, and in this class A we have an abstract method A. So this class B must provide the implementation detail for this method A, or else we have to declare the class B also as abstract. So overriding is compulsory in abstract classes. It may contain more than one. An abstract class can contain more than one abstract method, and you cannot create any object for this abstract class, and they cannot be instantiated with the new operator. So for example, let's say we are having a class named bike, and we have the abstract method run. So this Honda 4 method is inheriting the bike class. So here, since Honda 4 is inheriting bike class, this run method has to be given some implementation. So it is giving some body. So the Honda 4 class is giving some body for the run class. And we are creating an object of the Honda class and invoking the run method. So that's all for today's video. In this video, to prepare this video, I had used Java T-Point website, the Oracle website, and Samantha Sir's website, and the textbook Java Complete Reference by Herbert Schill, which is of the 9th edition. So thank you for watching my video. That's all for today.
Like, share and subscribe. Hit the bell icon for more updates.